lines parallel. Okay. So we're going to learn the postulates and theorems that can help you to prove that lines are parallel, and we're going to introduce a flow proof. Okay, just another way that you can do proofs. Again, not my favorite because I'm very logical and like the two-column proofs. Okay, so at the top of your paper were the 4 postulates that we learned about parallel lines and the transversals. So the first one, if 2 parallel lines are cut by a transversal, then corresponding angles are congruent. Take a minute and write down all 4 of the converses of those 4. Pause the video when you're done. Go ahead and check to see that you've done it correctly. So if 2 parallel lines are cut by a transversal, then corresponding angles are congruent. Its converse is if the corresponding angles of 2 lines cut by a transversal are congruent, then the lines are parallel. So we've got 2 lines. We don't necessarily know that they're parallel. This is how we would prove it. Okay, if 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. The converse would be if the alternate interior angles of 2 lines cut by a transversal are congruent, then the lines are parallel. And then just keep checking. I'll just keep forwarding. You can pause and check. Okay. So we have postulates and theorems, and we have the converses. The postulates and theorems all state that if the 2 lines are parallel, these things are true. So they're used to prove that angles are either parallel, are congruent, or they're supplementary. The converses all state that these are things are true about the angles. This makes the line parallel. So if you're trying to prove lines parallel, we use the converses. Okay. So which of the following 2 lines in each of these problems are parallel? Justify your answers. So sometimes using different colors helps you to do this. If I've got this line here, because here's my angles. Okay, they're touching that. So this lets me see that line P is parallel to line Q. Okay, and those are alternate exterior angles, so that would be the converse, okay, of the alternate exterior angle theorem. And that's an appropriate abbreviation if you would like to use one. Okay. Again, and actually by the same theorem, if we look at this next example, here it is, here it is. There's my transversal. So G is the transversal, and T is parallel to U by the same converse. Okay. So now I want to determine the values of x for which m is parallel to n, and then I want to find those measured angles. Okay, so if I look at my angles, this is 6x minus 44, this is 4x. Those are alternate interior angles, so we know they're congruent. So 6x minus 44 equals 4x. Okay. So if these lines are going to be parallel, they have to be congruent. So I'm going to what am I going to do? I'm going to subtract 6x from both sides. I'm going to get negative 44 equals negative 2x. I'm going to divide by negative 2, so x equals negative, dividing by negative 2, x equals positive 22. And if I want to find my 2 angles, 4 times 22 is 88. And then 6 times 22 minus 44 is going to be 132 minus 44, which is going to be 88, because they're alternate interior and they're congruent. All right, another example. This time my angles are here, and they are same side, and they're supplementary. If you can do this, they're supplementary. Okay, if I go back to the last example, if I make a Z when I include the transversal, in the angles, then they are congruent. Just a little hint. All right, so they're supplementary, which means that they add up to 180. So x plus 20 equals 180. So I'm going to get 2x plus 20 equals 180. If I subtract 20, I get 2x equal to 160. If I divide by 2, x equals 80. So this angle here is 80. And since they're supplementary, that angle there is 100 degrees. All right. Now, one of my least favorite proofs is the flow proof. Okay. But we got to do it. So this is how it works. We use a flow chart to look at the proofs and look at the steps. So if I know that 1 and 2 are supplementary and x is parallel to y, the first thing I want to do is mark my diagram with the arrow so I know that x is parallel to y because it helps me a little bit. I want to prove that q is parallel to r. So since we're proving lines are parallel, we know we're going to use a converse at some point. So in a flow proof, the steps are given in the boxes and the reasons are given outside. So x parallel to y is given. And then we have same side interior angles are supplementary. So that means we have same side interior or supplementary. The only same side interior we have are 3 and 2. So we say angle 3 and angle 2 are supplementary. Okay. 1 and 2 are supplementary is a given, so we're going to write given underneath that. Okay. So basically, those two reasons together, which is why they're stacked, because we're going to take them together, is going to give us 1 is congruent to 3. The reason I don't like this is because it leaves out a whole bunch of steps. So what steps is it giving up? It's giving up that the measure of angle 2 plus the measure of angle 3 is 180. And the measure of angle 2 plus the measure of angle 1 is 180. Okay, and then we would be putting these together. So that's one thing it's given up. Then it's given up that we can say that the measure of angle 2 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 1 by equals, they're equal. And when we subtract, measure of angle 3 equals the measure of angle 1 because we subtracted the measure of angle 2 from both sides. And so this would be a whole bunch of reasons. It would be from definition of supplementary to subtraction, okay, to definition of congruent. And then angle 3 congruent to angle 4 is because vertical angles are congruent. And then by transitive property, we can say that angle 1 is congruent to angle 4. So here I've got 1 congruent to 4, so that those are corresponding angles. So Q is parallel to R by the converse of the corresponding angles postulate. So it leaves out too much information for my comfort. So let's look at this next example. We're given that N is parallel to M, and it's marked, and 1 is congruent to 2, which I'm going to mark right now. And I want to prove that P is congruent to R, so it might help to highlight what you're going to prove, okay? So I'm going to start my proof. Okay. The first thing I'm going to state is that n is parallel to m, and that's given. Okay. I've only started one part of the given because I'm going to use what directly follows. So if n is parallel to m with the marked angles I've got, now if you had more angles, there was lots of different ways to go about doing this. But right now I just have 1 and 3 on n and m. So those are alternate interior angles, and we're going to say that those are congruent. Oops, going backwards. Okay, so 1 is congruent to 3 by the alternate interior angles postulate. So angles are congruent, we use the postulate or the theorem. Okay. Then I'm going to state that 1 is congruent to 2, and that's given. So that's more directly. So since I've got 1 congruent to 2 and I've got 1 congruent to 3, hopefully you're seeing now that we're taking out the middleman, and we're going to jump to 2 is congruent to 3 by the transitive property. And now that we've got that, we can state that our lines are parallel. P is parallel to 9, so by the converse of the alternate interior angle theorem. They're alternate interior angles. So it is done. We've proven it. All right, so today we looked at parallel lines and transversals. We've learned to prove. We have to remember that to prove angles congruent or supplementary, we're going to use the postulates or theorem. And to prove lines parallel, we're going to use the converses of those postulates and theorems. So on 3, ready everyone? Have a math-tastic day.